Finite, and welcome to lesson 2.4.2 application notes. I know a few of you already did this problem, so you can skip ahead to the next one, but if you didn't or you needed a refresher, here are some notes on applications of our system of linear inequalities. Okay, so first off, a bakery is preparing change cookies to cupcakes. I know that'll make sense later. And sheet cakes for the upcoming week. They know that they must make at least 20 dozen cupcakes and at least 10 decorated sheet cakes. Okay, it takes 2 hours to bake 1 dozen cupcakes, 6 hours to create a decorated sheet cake. The bakery has 3 dedicated bakers who can each work up to 48 hours. Okay, so what we have here is an example of a system of linear inequalities that will end up graphing, and where our shading intersects is going to give us different combinations that can help satisfy the bakery's demands. There's different ways they can go about making their cupcakes and sheet cakes to satisfy their scenario here. So write a system of linear inequalities. So first off, it's a good idea. We're going to let x be our cupcakes. So always identify your variables and let y be your sheet cakes. Okay, cupcakes. So we have a few different equations that we're going to need. Let's look first at what we have. They must make at least 20 dozen cupcakes. Okay, so our cupcakes at least is the expression greater than or equal to 20. Okay, next up, at least 10 decorated sheet cakes. How that can be represented is that y needs to be greater than or equal to 10. Okay, now this next bit. It takes time to bake all these things, and unfortunately time is not unlimited. We have limited time. It takes 2 hours to bake a dozen cupcakes, so that's 2x, and 6 hours to create a sheet cake, plus 6y. And what they're limited by is the bakery has 3 bakers who can each work 48 hours. Okay, the common tendency is to put 48 on the other side here. So we know we're limited, so we can only work or bake up to this certain amount. So it's going to be less than or equal to, because we don't have more time. The bakery has 3 dedicated bakers, 48 hours. So you'll take 3 times 48, and that will give you the number of hours we have available to bake. So 3 times 48 is 144. Okay, those are the equations. So you'll be getting points for, of course, listing the equations, but you do want to graph them. And we are graphing with inequalities, so we need line type, and we need shading. Okay, and don't forget labels. Okay, little things. Little half point things here and there. So on the x-axis, we have our number of cupcakes, and that's in dozens. And on the y, we have the number of sheet cakes. Okay, x greater than 20, that should just be a pretty easy one. That's going to be a vertical line through 20. Okay, and if we're thinking of shading, greater than 20 would be everything on this side. Okay, so there's our x that is greater than 20. Y is greater than or equal to 10. So we have our horizontal line at 10, and greater than is everything above. That went a little below. Let's be a little more proper here. And then the last equation, you could solve for y, but please remember the x and y intercepts. It's going to make it much easier because you're going to get fractions. Sometimes the units on the graph aren't perfect 1. So remember, we can find the intercepts. I recommend the table method. And really what this means is when we plug in 0 for x, what do we end up with for y? So 2 times 0 is 0. So we end up dividing 144 by 6. 144 by 6. And that gives it 24. Okay. So right now we have the point 0, 24. about here. And substitute 0 for y, and then you divide 144 by 2, or a simple 72. And that's on the y. Whoops, mix these up. So 0, 24, 24 on the y-axis, good catch there, and 72 on the x-axis. Thanks for fixing that up. Anyway, we're going to connect these. And shading-wise, it's everything below. So everything below this line, since we are limited on our hours, is going to help us out. Now, the actual satisfactory solutions are in the triple shaded region. So when it asks to list at least 3 combinations, you're going to generally want to pick the whole number ones. So there's 3. Really, you could pick anything on any of the lines. Okay. But I'm not looking for anything too crazy. It just has to be something within that region. So possibilities for our bakery, possible combinations are, you can say 25 and 12, 25 cupcakes and 12 sheet cakes. So make sure you do have units, or you specify them at 1 point. You can say 30 and 12. And if you wanted, you could say 30 and 14. But really, there's a variety of answers here. So those are just 3 of them. Anything, again, within that triangle, I will accept. Okay, so setting up the equations, often the hardest part. Remember your graphing techniques. Okay, use the table, especially for most of these problems. That makes it nice for you. Okay, moving on to the next example. Okay, a shop that creates and sells snowboards and skis. So they must produce at least 20 items. Okay, warehouses sometimes have demands that they need to have at least so much produced in order to sell, of course, their items, and also just to keep people employed. It takes 3 hours to create a snowboard, 4 hours to create a pair of skis. There are 6 machines that can each work for 20 hours nonstop, but will malfunction if they work over. Produce at least 4 snowboards and at least 2 pairs of skis individually. So let's work on our scenario. Let's let X be our boards and Y be our skis. Okay, always start with identifying those when in doubt. That way you can go back and look. So they have to produce at least 20 items. Whether those be skis or snowboards, we're not sure. So X plus Y must be greater than or equal to 20. Okay, now we have our time. It takes 3 hours to create a snowboard, 4 hours to create a pair of skis, and there are 6 machines that can each work for 20 hours. Okay, so 3 hours for a snowboard, 3x plus 4y is less than or equal to, so time is usually always less than 6 times 20. 6 times 20, you should know, I should know, is 120. So 6 machines, 20 hours each. That's how I got the 120. Now, the next little thing, shop must produce at least 4 snowboards. That means X must be greater than or equal to 4. At least 2 pairs of skis individually. Okay, so that's why we can just split these up. And now, yes, we have 4 equations, but you can still graph them. Labels, so we have our boards on the X, and we have our skis on the Y. Let's get the easy ones out of the way. X is greater than or equal to 4. Okay, so 4 is about here. Won't be too picky with that. 2 is about there. Okay, at least, so as you're shading these, it is a good idea, of course, to shade as you go. If you just want to leave general notes to yourself as to where the shading is, I've seen students do that before, that's fine. These are just arrows saying, hey, I'm going in all these directions. Okay, so those 2 are done. x plus y is greater than or equal to 20. So x plus y greater than or equal to 20. You could solve that one for y, or you could use the table method. It's pretty simple if it's just this here. If you substitute 0 in for x, you have y is 20 and 20 otherwise. So 20 to 20. Let's get that in. Now this one is everything greater than, so we're still going in this direction. Okay, at least 20 items. So time, hopefully, is going to cut off some of our options here. We'll make another XY table. 0 in for x means 120 divided by 4, which is 30. 0 in for y means 120 divided by 3, which is going to be 40. And so 0 to 30 and 40 to 0 is our last little equation. Now, in this particular case, it's everything below. So everything below this line. And what we end up with, and it might be a little difficult to see at first, is this little awkward shape right in here where the solutions are. So again, any combination now within here will work. So you just need to list 3. There's really kind of an infinite amount, but whole number ones are the key. Can't make a part of a snowboard or you're going to be in rough shape, or one ski out of the pairs. So anyway, so possible combinations, possible combos with units are 15 to 12, 15 boards, and 12 skis. You can also have 25 and 6. Okay, 25 boards and 6 skis. Or maybe we're feeling more skis, less boards. 10 boards and 16 skis. Okay, so I'm definitely going to be checking your graphs, and of course, do you understand what those mean? Okay, that is a general idea. Please be practicing these. There are 3 problems similar for you to practice. Answers will be up online. I may even make another video going through those to help you out. So give your best shot at the application practice problems. Start by, of course, labeling out your variables. Get nice graphs, and good luck, guys. Nice job.